Alright, so this is for Pre-Calc 11, Chapter 2, Section 3, just the introduction to the sine law. Okay, it says here, so far you've learned how to use trigonometry when working with right triangles. Now you learn how to use trigonometry for what's called oblique triangles, non-right triangles. In fact, they use the sine law and cosine law a lot in science. And for example, when they try to figure out how far planets are from Earth, they actually use this exact same principle. Okay, so I'll show you exactly how that sort of looks like. It says here, draw an oblique triangle ABC and label the sides little a, little b, little c opposite the respective corresponding angles, which just basically means capitals for angles and then lowercase for the opposite side. Okay, it says then draw a line called H, which is height from capital B to little b, so that it is perpendicular to line B. Okay, so let me just draw for you what this says. Okay, so again, my drawings are like not very good. Anyways, so here's your triangle. And of course it is not a right angle triangle, so capital A, capital B, capital C. And then of course little c, little b, and then little a. And it says draw a line H from B to B. So we're going to call that H. And perpendicular, well, that means they're right angles, right? Okay. So now it says write a ratio. Write a fraction for sine A. That means here's my target angle, right? My target angle is A, so sine of angle A, well, that's going to be H, right, opposite over little c. Now if we do a little bit of algebra, I can rewrite H as the height of the triangle is C. The height of the triangle is C times sine of angle A. Okay. Now, can you write a ratio for sine C? Well, here's my target angle. That means I'm standing here. That means opposite over A, right? So sine of capital C is, again, H over little a. Now, what does that mean? Well, doing a little bit of algebra, we can isolate H, just like we did earlier. H is equal to A times sine C. Now, hopefully you would agree that it's the same height for both these expressions. So if this is the same H as this, that means I can make C sine A and A sine C equal to each other. That means C sine A must equal little k A sine capital C. Alright, now that's going to be kind of useful. It says here, since each ratio is equal to H, they must also equal to each other. Well, that means I can rewrite this expression like this. I can divide both sides by little a, and I can divide both sides by little c. And so now I have what looks like sine angle A over little a is equal to sine of angle C over little c. Hey, so do you sort of see a pattern here? It looks like the angle and the corresponding side, that means we can continue on. We can do this, sine of angle B over little b. Now, these ratios or these fractions are all equivalent, but then you can flip the fractions as well, and you can write it like this, A sine capital A, lowercase b sine of angle B, lowercase c sine of capital C. They mean all exactly the same thing. Alright, and the reason that we can do the last ratio is that it depends on how you do H. We could have done H this way, right, perpendicular to C, and then we would have come up with a new expression. So here's the sine law, and this works for all non-right angle triangles, okay? I shouldn't say all. What we want to do is you know that when it comes to ratios, we just need a pair of them to equal. Right? So we need what looks like 4 pieces of information, and we need to know 3 of them, all right, in order to find the 4th. So that's key. We need 3 pieces of information to find the 4th. Okay? So here we go. It says here, solve for AB. And sometimes some questions will have these lines on them, and that refers to line segments. So solve for AB. So I want to know this side length. Okay. Now that's opposite angle C. So why don't we just call it little c? Now BC, that's down here. Why don't we call this little a? So I'm not going to call it AB or BC anymore. I'm going to call it little c and little a. Alright, so if I'm looking for a side length, alright, here is another important key, and it's going to make life so much easier. Notice that you have what looks like lowercase on the top. That's one version of the sine law, and then lowercase on the bottom. If you're looking for side length, grade 11s, if you're looking for side length, use this version of the sine law, okay, where the lengths are on the top. Okay, so here we go. If I'm looking for length C, I know the corresponding angle is 35, so I'm going to go C over sine 35. Now, I know one out of the two pieces of information. Is there the other two that I know? Oh, I know these two. Right? This is angle B, 115. This is length B. So I know that I can write the ratio like this, B over sine 115. So let me show you what this means. I'm going to erase B, and I'm going to replace it with this numerical value, which is 73. Okay? Why did I write 5? 73. Okay. Now, I do some cross multiplication, or I can just say these two multiply each other, right? So C is equal to 73 times sine 35, all divided by, all divided by sine 115. Okay? Now, you got to be extra careful using the calculator. Again, here's my calculator. Make sure it's in degree mode. And let's turn it on. So here we go. I always do this. Bracket, in the numerator, 73 times sine 35. Now my calculator happens to have a bracket for the angle. So I'm going to close the bracket, divided by sine 115, close the bracket, equals a length of 46 point, one decimal is fine, 46.2 meters. Okay, don't forget your units. Now, we're looking for length A now. So again, if I'm looking for length A, I must have to know what this angle is, but I don't. Or do I? Oh, well, I know that the sum of the angles in a triangle must be 180. So if this is 115, this is 35, I automatically know what that is. So angle A, right, measure of angle A has got to be 180, subtract 115, subtract 35. That's going to be, I think, 30 degrees, if I'm not mistaken. So 115, 140, 150, yep, 30 degrees. Okay, so that's handy. Alright, so now, okay, so in order to find length A, I'm going to go A over sine the angle, right? Do I have a pair of corresponding angle inside? Well, again, I'm going to use these guys, and it's going to be 73 over sine 115, and again, 115. Grade 11s, if you're looking for length, set up the problem with A in the numerator, okay? So then A is equal to 73 times sine 30 over sine 115. Alright, so take my calculator out, move it over, and it's going to be 30, it's going to be 73, let's try that again, bracket 73 times sine 30, close bracket for the angle, close bracket for the numerator, divided by sine 115. Close the bracket for the angle, 40.3 meters. Okay, 40.3 meters. There you go. All right. Next example says here solve for angle B. All right, so now we're not solving for length, we're solving for angle B. So instead of putting the length in the numerator, we're going to put the length in the denominator this time. Okay, it's going to make life easy for you. All right, so we know angle A, which is 50. That means we know length A. So we need to use this pair. Okay, we need to use this pair. So here we go. Because I'm looking for an angle, I'm going to put sine in the numerator. Now sine of angle B over 5 is equal to sine of angle A, right? That's the pair we know, over 4. Now sine of angle B is equal to 5 times sine of 50 over 4. Right? So super duper easy. We just multiply straight across. We're going to use my calculator, wherever the heck it is. Okay, there we go. 5 times, I don't need all those brackets anymore for this case, okay? 50. And then divided by, because the calculator automatically will do the multiplication first, okay? Divided by 4. Now, it says it's 0.9575555, but that's not an angle. That's only in ratio, all right? So how do I find the actual angle? So measure of B is actually sine inverse, okay? So sine inverse, if you want, you can copy the decimals down, or you can just copy this down. 5 sine 50 over 4. Depending on what kind of calculator you have. My calculator remembers the last answer. So what I can do is I can go second function sine, right? It's got to be the inverse. My calculator remembers the actual decimal places, so it's second function answer. So it remembers it's 9575555. Your calculator may or may not be able to do that. If it can't, you can just plug in 5 sine 50 over 4. It does the same thing. Alright, so there we go. 73.2 degrees. So measure of angle B is equal to, let me just scroll up a little bit, 73.2 degrees. Now, what's the measure of angle C? Well, we know the property that all triangles, their angles must equal to 180, so it's going to be 180 minus 50 minus 73.2. I can't do that in my head, so it's going to be 180 minus 50 minus, oh, and my calculator remembers the last answer as well. So it's 56.8-ish degrees. Okay, grade 11s, don't forget to put your degree symbol. And of course, help Mr. Chin out because he can't read. Put a box around it. Alright. It says here, for oblique triangles, what's the minimum information needed in order to use the sine law to find new information? Well, the minimum, alright, is you need one pair of corresponding, alright, that means you need an angle and one side. That's to start off with, and then you need one other piece of information. One other, either, alright, hopefully I spelled that right, a side or an angle. Okay, so that's the bare minimum. Alright, moving on. It says here, when solving a triangle, you must find all unknown angles and sides, sketch and solve the triangle. Each answer to the nearest tenth, which is just one decimal place. Okay. So I'm going to draw. I'm going to draw a triangle, and of course I'm going to apologize now because my triangles are just like terrible. Okay, it's not a 90, so don't draw a 90. I'm just going to go A, B, C for no other reason. I know that this is going to be 140. Angle C is 25. Okay, I don't have any other information. Oh, I do. Length A, that's over here, that's 20. That's a corresponding pair, okay? Now, we actually know what angle B is, right? because the sum of the angles in a triangle is 180. So that's 140, 25. That's 165. I think angle B is 25 degrees. Now, the word solve means we need to find everything else. Okay? This is not SOHCAHTOA. We're not doing SOHCAHTOA. There's no 90s in here. So let's start off with the pair that we do know. We know 140 and 20. So we're looking for sides, right? We're looking for little c and little b. So I'm going to set it up so that little b and little c are on the top. So b over sine 25, 25 is equal to 20 over sine 140. And I just multiply these two. So b is equal to 20. Always put the coefficient in front, grade 11s. Always put the coefficient in front. Sine 25 over sine 140. I'll take my calculator out. Okay, so this is going to be 20 sine 25. I don't actually have to hit multiply. The calculator automatically knows its multiplication. Divided by sine 140. Okay, don't forget to close the brackets for the angles. So it's a length, right? Little b is a length, 13.1. Or 13.2, depending on how you want to round. Okay, is there any units? Nope, no units. Okay, so it's 13.2. Now I'm looking for little c, so I'm going to set up c on the top over sine 25 is equal to, and I always use the pair that I have, okay? I always use the pair that I have. Don't use the pair that you just calculated because there's some rounding. Alright, so use the pair that you already have. So that's going to be 20 over sine 140 and, sine 140. And notice, again, we're just going to multiply these. So c is equal to 20 sine 25 over sine 140. So 20 sine 25, I don't actually have to hit multiplication, divided by sine 140. 13.1. And we know again there is no 13.1 or 13.2. And that sort of should make sense. There's no units. Why does this have to be very, very similar? Well, if you think about it, it's sort of like your mouth. If your mouth can only open up 25 degrees, let's say your brother or your sister can only open up 25 degrees, and you can only open up 25 degrees. Chances are you can only eat a sandwich about the same size, right? So that's one way of sort of guesstimating. It's not super duper accurate, but it's guesstimating. If the angles are identical, that means the side lengths opposite should be identical as well. All right? So that's a bit of a hint. Last example. Again, I'm going to apologize. My drawings are terrible, but anyways, here we go. For no reason. It's not a 90, okay? A, B, C. So that's 38. That's 8. So that's the corresponding pair that we have. And then we have A is 6. Right? Here's my A. That's 6. So now it says solve. So I'm going to use, I'm going to try to find angle A for sure. So I'm going to put sine of angle A in the numerator over 6 is equal to sine of 38 over 8. Now, you can sort of imagine 38 degrees opens up to a sandwich that is, let's say, 8 slices of bread thick. This is only 6 slices of bread. So your angle A, all right, your angle A better be smaller than 38. So that's one way of checking. Now, sine of angle A is equal to 6 sine 38 over 8. We're not asking for sine of angle A, we're asking for measure of angle A. So measure of angle A, now I'm going to have to do the sine inverse. Sine inverse of 6 sine 38 over 8. And it better be smaller than 38 degrees. Okay, it better be smaller than 38 degrees. So second function, sine inverse. And notice it's got a bracket, so it's going to be 6 sine 38. So you got to be extra careful. There's 2 sets of brackets that you need to close. Oops, sorry. divided by, okay? So the open bracket, you have to punch all of this in. Close the bracket. All right, so just double check. You have 1, 2 open brackets, 1, 2 closed brackets, and the closed bracket must include the denominator. There you go, 27.5 degrees. Angle A is 27.5 degrees. And is it smaller than 38? Yep, it is. So our guess is good. Now we automatically know what measure of angle C is, right? Some of the angles in a triangle is 180, so it's going to be 180 minus 27.5 minus 38. I have no idea what that is. I have to, of course, use a calculator. 180 subtract 27.5 subtract 38 is 114.5 degrees. Okay, so we have 114.5 degrees. Put a box around that as well because that's important. We're almost done solving. We just need to find length C. Alright, so now we're looking for a length. Okay, well now I'm going to put length on the top. C over sine, what was the angle C again? I think it was 114.5. Now, use the pair that we have. Alright, use the pair that we have. We have this pair. So it's going to be 8 length over sine of 38. Okay, because we put length in the numerator, now we have to set it up with the length in the numerator for the other pair that we're comparing to. Okay, so C is equal to 8 sine 114.5 over sine 38. And we're nearing the end. I apologize, this video again is slightly longer than I had hoped. Okay, so 8 sine 114.5, close the bracket, that's the numerator, divided by sine 38. Close the bracket. So we have a length of 11.8. And I don't think there's any units. Was there any units? No units, okay. So when it comes to solving, there you go. Okay? Hopefully that makes sense.